see the next basic element, that is an literal constant. What are literal constants? So literal constants are constant values or constant data expressed within a program. Okay? Constant values or constant data expressed within the program is called as a literal constant. For example, if you take a program here, okay, a main program, main function, where I give here a value is equals to 10, or b value is equals to 3.5. So now this 10 and 3.5 are nothing but data which is expressed within this program. So these are called as an literal constants. So there are two words used in this. One is an literal and second one is an constant. Now, literal word is used because I can talk only in terms of its value. Okay, this 10 I can talk only in terms of its value, hence it's the word literal. Constant because in a program when you have given 10, automatically the program value here, this will not change to an 20. It will remain constant. Okay, until you change your programming code and go to this place and make it as 20, it will not change. So for that reason, a word called as a constant. So in term, any data which is expressed within the program, any value which is expressed within the program is called as a literal constant. And we'll see what are the different types of literal constants available in a C language. What are the different types of values you can express within the program. Now, when I give here value 25, okay, 25 directly, so this value is going to be nothing but an signed short integer value. So in a program, if you give here, like in a program, if I give x equals to 25, this value is going to be of type signed short int. That means it's a 2 bytes data. Okay. Same way, if I want to specify the same 25 as an unsigned data, unsigned short data, unsigned short integer data, then it has to be given as 25u, or else you can give 25 uppercase u. Both will do. Okay. So this, when you postfix with an u, then that value becomes an unsigned short integer data. But this both the data, both literal constant is of 2 bytes. But the same 25, if I want it to be an 4 bytes value, 4 bytes data, that is an signed long integer data, then you have to give it as an 25L, or else you can also give it 25 uppercase L. So this is going to be an signed long integer data. Same way, that same data, 4 bytes data, should be an unsigned long integer data. Then you got to give this as a 25LU, or else you can give 25UL, or else you can give it as a 25 uppercase UL, or else 25 uppercase LU, and combination of both uppercase and lowercase. So this data becomes an 4 bytes data, but it is an unsigned. That means all 32 bits are of an data bits. So all these four are decimal value. Okay, there is nothing but base of 10 value. The same thing, if you prefix with a data, if it is prefixed with 0, then this data becomes an octal data. Okay, it's an octal data. Now if you take up an integer variable x and then try to give it x is equals to 031, and if you try to display the same value by giving a printf %d and then x, it's not that 31 will be stored or 31 will be stored, will be displayed. It will display here something called as 25. Why? Because this data what you are assigning here is not a decimal value. Because it is prefixed with 0, it is an octal value. So why it is displaying 31? So here you are given, while displaying, while asking to display, you are given a %d. That means you are asking to display a decimal value. So what happens is, this is 31, it's an octal value. If you want to convert to decimal, you got to multiply it by 8 raised to 0 and 8 raised to 1. 8 raised to 0 is 1 and 8 raised to 1 is 8. So here 8 3s are 24 plus 1, it's going to be nothing but 25. So you get here 25. But if you want to display as it is octal value, that is 31, instead of percentage %d, you have to give a percentage %. So any data which is prefixed with 0 is going to be an octal value. Okay, fine. Now octal value ranges only from 0 to 7. There are only 8 digits. Okay, so in that case, octal, you cannot give a value as in 038 or 039 is not possible. So 8 is not a valid digit. So compiler will raise an error message for this. So you can give, if your prefix means 0, the data should be only ranging, digits should range only from 0 to 7. That's going to be an octal data. Same way, if you want to give an hexadecimal value, okay, hexadecimal value, then the value has to be prefixed with 0x. Any data which is prefixed with 0x, then it is being treated as an hexadecimal value. So you can give here 0xA1, because hexadecimal digits ranges from 0 to 9 and remaining 6 characters as an A to F. So you can give a value as an 0xA1. For example, if you have declared an integer variable x, and if you give here x is equals to 0x19, and then you give a printf %d and then x. So this 19 will not be displayed because you are asking it to convert it to decimal. So this 19 will get converted to a decimal value. For that, you have to multiply it by 16 raised to 0 and 16 raised to 1. 16 raised to 0 is 1 and 16 raised to 1 is 16. So multiply this, it's going to be a 9 and then 16. 9 plus 16 is going to be nothing but 25. Here, even in this case also, it's going to display 25. Okay. So any value can be given here between 0 to 9 and A to F when you have prefixed with an 0x. Okay, that's anything prefixed with 0x, it is an hexadecimal literal constant. Only if you prefix with 0, then it is an octal, and if you don't prefix with 0 or 0x, then these all 4 types are an decimal value.